Hi, good evening. Can you hear me? Oh,
Hello, good evening. Yes, I'm hearing you, sir.
okay. Just waiting some minute. Now we start.
Okay, no problem, no problem. Assalamu alaikum.
Alaikum assalam. Okay, so can you hear me? Yeah. Uh,
Hello, sir. Yes, I
yeah.
am
So
hearing you.
okay, so let's really start. So basically, first of all, I discuss about for the problem solving. So if you have any
Uh,
problem, if you can easily share the screen and show me the problem, we try to discuss about the problem. Okay.
okay. Thank you so much.
So let's.
Sir, I have start with the Google Earth Engine.
Okay.
So in the GEE, I have no problem. But especially I face problem in other to the Jupyter Notepad and Anaconda. Let me share my
Yeah.
screen with
Please, the
you, sir.
share the screen. Yeah. So I can see your screen. Yeah.
Thank you so much, sir. First of all, sir, I have run this code, so it runs very easily and accurately.
Yeah. So now
But
run
when
again. Yeah. So
so,
now run again. The
oh,
first
okay, okay.
step. Yeah. So run it. Yeah.
Sorry, my yeah, it works. So when I add another one,
Cool.
so then
Click on the allow. Yeah.
yes. So I have already used this email address of the GEE. So I'm giving the authorization. Continue. Sorry, I have a little bit slow internet connection here in
Okay. No
China.
problem.
As the Google. So then when I press the continue,
That your same email, which email address you use in the full collab, and also use the Google Earth Engine registration.
yes. I already used this email in the GEE, Google Earth Engine,
Okay.
and also here. So here it gives me the two options like see, edit, create, and delete all of your Google Drive file, and see, edit, configure. So should I check these two or
Yeah,
not?
yeah, check all of this, all of the checkbox. Simply check, click, and then
Okay.
it a square box checkbox. Just click the both of checkbox, then press the
Yeah.
confirm.
Yeah. Before that, I couldn't check both of these
So
options. So
that's how it
that's why
create the
maybe.
problem. That's how it create the problem.
Yeah. Maybe. That's great.
Yeah.
Now it's okay.
Okay.
Before that, I have tried 3 times, but I couldn't select that 2 tips. So from here onward, I will continue further with the
Yes,
help of
yes,
that video.
yes, yes,
This
yes.
problem is solved.
Okay, thank you. Okay.
Most welcome, sir. And another problem in the Jupyter Lab, Jupyter Notebook.
Okay, just open it.
Just yeah, just let me check it here. Mm, Just let me share the screen. Should I stop sharing this one and then I will share you
Yeah,
the
yeah, yeah,
another
yeah,
window?
yeah, okay.
Thank you.
Or share the entire screen, then it will be show all of screen.
Okay, okay, sir. Also share it. So is it okay now, sir?
Yeah, okay.
Just let me refresh this one. Mm. So I face this problem when I'm going to import both of these libraries. So it gives me this option: no module name
Okay,
GEE
so
map.
okay, so first of all, we need to install the GE map Anaconda prompt. So just simply open the Anaconda prompt. Search on your type here or search. You can see the just open the Anaconda
Uh,
prompt. Yeah, here. Anaconda prompt. Yep. And did you create any environment or not?
yes, I have already created the one
Okay.
environment with the help of your video, and I named them like special
Just simply put
name.
here the conda activate, then put your environment name,
Wait.
then put the name.
Uh, I forgot his name, but maybe you mentioned in the video like special.
We can also check it. We can also check it. This type of name. Just open the Anaconda distribution. You can see you already open this in the. I can check the bottom on here.
Here.
Yeah, yeah. This one just open, and then you can see the
Uh,
environment. Click on the environments. This one. So now it's show you that all of environment which you create. You can create the geospatial. Your environment name is
yeah,
the
juice.
geospatial you create. So just simply use it. The prompt
Okay.
option.
Conda activate juice
Geospatial.
special
Just try.
SP. Just let me check the spelling. SPATI. SPATI. So should I press enter?
Yes.
Yeah, it's
So now I
run.
can see it show the geospatial. So now in geospatial simply write the code for install the conda, like install the GE map. So further just write the same code conda.
Conda install GE
We
map.
need to okay. We need to use the 4G conda 4G. Okay, let me write the syntax. Just a minute. I send you the inbox. Just a minute.
Okay.
Let me send. So let me write in the chat box. Then you can get it easily.
Yes.
Right.
Yeah, it will. It.
So GE map. I just this copy these things and then paste conda
Okay.
install
Thank you
GE
so
map
much.
C conda 4G. it
Is it okay like Conda install you may? I have just copy and paste it here and press enter.
yeah. You can paste the 2 times. So conda install gmap c conda 4g, just one time to use it.
Ah, so I will cross it again in Conda. Mm. So is it okay? Conda install Jumate.
Gmap c conda 4g. Okay,
See,
now.
so I press enter.
Right.
And besides this, sir, can we plug in the Arc map with the Google Earth engine or not?
ArcGIS Pro is possible. Connect the
Oh,
Google Earth engine. But ArcMap it also possible. But for that we need to download the data. GeoTIFF file data we need to download. And for that the GeoTIFF file format we need to import in the ArcGIS, mainly ArcMap
yes, yes,
possible. But we can
yes,
directly use the ArcGIS Pro to connect the server of Google Earth engine and download all of data easily using the ArcGIS
yes,
Pro software.
yeah. So Arc GIS Pro is also GIS Pro is also okay. ArcGIS Pro instead of Arc map only. So sir, yeah, it's 3 chain terms of Pro service
It's
accepted.
working. It's working.
Yeah.
It's working. It's loading the all of
Mhm.
dependency, all of packages installed
Yes.
in your system.
Yeah.
It's just need only for the one time. After that, you not need. Just simply open the work and then first time we need to install this package.
Ah, so after that, then we will directly work in the Jupyter notebook.
Yes, yes.
Oh, oh, thank you so much, sir. So should we will start the class? I will try this, and if there
Okay.
is any problem, maybe tomorrow we will discuss
Okay,
it
no
again.
problem. No problem. It's
Oh,
loading.
oh,
No problem.
oh,
Okay.
yeah. Oh, thank you
So
so
let's go.
much.
Let's
Just
start.
let me.
Okay. So now let me share my screen.
Yeah.
So basically, we discuss about that mainly this type of topic, how to work with satellite images. Okay, how to filtering and displaying the satellite images. It can be Landsat, Sentinel, Modis, or any other satellite images, how we can easily filter. We also discuss about that. And how to create the satellite composite, different types of satellite composite, and how to create the band combination, then export the satellite imagery. It can be Landsat, Sentinel, Modis. and how to use import, filter, reduce, clip, and display the raster in Google Earth Engine. We'll also discuss about that. And time series analysis, how to make the time series chart for the different types of indices using ready-made dataset. We also discuss about that. And how to export any shape file. Then we talk about the annual image composite, how we can easily work with that. Okay. So let's go. We'll start our class today's session. So first of all, okay, so let me open the code editor first. So previous class we discussed about the total 5 types of data in Google Earth Engine. Basically geometry, then feature collection, image, and image collection. Okay. And we are just use this type of data. Total 5 types of data we always use in Google Earth Engine. So from here we simply use the one data set. Today we discuss about that image collection. Okay. So how to work with the image collection in Google Earth Engine, and how to filter the image collection, how to choose the image collection. So all of those we try to explain one by one. So today our main topic for image collection. Okay, how to work image collection. So what is the image collection? Image collection basically set of images or series of images. Okay, so this is the image collection. Okay, and this image collection, it can be any image collection. Okay, not only for the specific, any image collection. It can be Landsat image collection, it can be Sentinel-1 image collection, Sentinel-2 image collection. And how I can get the idea it's a image collection? So if you simply visit the link, you can see the browse data catalog, then we can get all of dataset in Earth Engine, and it's called the Earth Engine data catalog page. Okay, it's called the Earth Engine data catalog page. In this page we can easily get all of data set in Earth Engine platform. If you check, we can get the some climate and weather data, surface temperature, climate, also atmospheric data, different types of weather data, different types of imagery, mainly Landsat image collection, then Sentinel image collection, then Modis image collection, as well as different types of high resolution image collection, different types of geophysical data, terrain data, land cover data. So different types of data we can easily access from here. As well as if you check the different types of tab, so you can see the Landsat tab. Just click on the Landsat. So now it provides you all of Landsat image collection. You can see the Landsat image collection for Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all of image collection you can easily get from the Landsat tab. Just click on the Sentinel, then you can get all of Sentinel image collection for the Sentinel-1 SAR data, Sentinel-2 multispectral instrument, yeah, this type of data. Also you can see the Sentinel-3, okay, Sentinel-5 P data. So all of satellite image collection you can easily access from here. Then click on the Modis, then you can get all of Modis image collection. Modis, it gives the different types of product. Also you can see that some product is a daily product. Daily product means that it give you the every single day information you can get from the daily product. Some product is the monthly or 8 days. So different types of interval product we can easily get from here. It provides a lot of data. So basically this type of data call as the image collection. Okay, Landsat image collection, Modis image collection, Sentinel-1 image collection, Sentinel-2 image collection. So different types of image collection, how we can easily work. Okay, basically the image collection, when you work, all of image collection are the same process. When you work, all of image collection the same process. Landsat, Sentinel, Modis, or others, all of image collection are the same process for filtering or displaying or exporting or creating the composite or creating the band combination. All of image collection are the same process. If you know how to work with Landsat, this same knowledge you can also apply for Sentinel. You can easily apply it for the Modis. So it's called the image collection. And if you check in the image collection from the docs tab, then we can easily get image collection, all of information. It is ee.image collection. Okay, and if you check, just click on here, then you can get all of information. Basically this type of function we can only use for the image collection data type. We can only use. So first of all, if I show you the one example, it will be more better. So just click on the lens set. So you can see the lens set, we can get all of image collection information. Suppose I want to work with Lancet 9. Okay, Lancet 9, if you check, it's available between this time period. Lancet 8, it's available between this time period. So different tickets, we find out the different collection of Lancet. You can see this is the Lancet 5, Lancet 7, Lancet 1 to 5. So this is, it's available between this time period. So you can get this type of image collection. So all of image collection are the same process when you work for filtering, displaying, or exporting. It's the same process. Suppose I will show you the one example for the Lancet 9. Same example you can also apply for Lancet 8, 7, or others, or any image collection. Just apply the same process. So first of all, I simply click on the Lancet 9. And then if you check, here we find out that this is the Lancet 9, OLI TIRS 2 collection. And here we find out, if you check, the Lancet have different types of reflectance value. Okay, it provides that multispectral, different types of band, and also thermal band. We also find out from here. So if you check, it's called the surface reflectance. Okay, and you can see the surface reflectance, it's already atmospherically corrected surface reflectance, as well as you can see the top of atmosphere reflectance. It also atmosphere reflectance, calibrated top of atmospheric reflectance. Okay, so basically this type of sensor or this type of data were used for the different types of purpose. So further we also discuss about the more details. So in this case, suppose I want to work with surface reflectance, this data I want to work, just click on here. So then we can get all of information about this image collection. If you check, this is the Landsat 9 level 2 data, collection 2, tier 1, and this data set is available between this time period, 31 October 2021 from 22 December 2025, and it also updated. Okay, so this is the last time period for this data. And this data set provider, if you check, this is the provider. It's called the USDS, mainly USGS Earth Explorer. It's provide this data, and every image collection, if you check, it's a image collection. Okay, so ee.image collection, this is the function. This function basically identify the image collection. Image collection, what is the image collection? Image collection is the series of images or set of images, and in this image collection we find out it's one kind of directory. Okay, it's called the directory or snippet ID. Mainly in Google Earth Engine have a server. So this data set or this image collection is stored in this server. Okay, so this is the directory of this image collection. Basically this folder, it is stored all of those in this directory, and every image collection we find out this type of directory. Okay, so just I simply copy this image collection snippet ID and paste in the code editor. Paste. So now this is the image collection, this function, and this is the directory. Directory basically it is stored this image collection in the Google Earth Engine server or Earth Engine data catalog. So now these things we simply store it in a variable. Simply create a variable and put the variable name. I put the variable name, suppose data set, then equal. So now what happened? So just I simply import this image collection in my code editor and then create a variable. So now this variable is stored this full image collection. Okay, this full image collection is stored in this variable. So now let's check how many images are available in this collection. I want to check it. How many images are available in this collection? So for that, simply use the print function. And if you check in this section, we find out a one function. It's called the size function. If you check size function, this function, just click on here to check all of information. So this size function, mainly it returns the number of element in the collection. So in this collection, how many images are available? We can easily get it when I just use the size function. Okay, this size function when I apply. So just I simply call the data set Basically, this data set is stored the full image collection. So just I call the data set this variable and then apply the size function. Size function. So now when I run the code, it just show the result, how many images we find out. Okay, we find out. So it's computing how many images are available. Collection for the whole world. Okay. So we find out that this is the total number of image collection for the whole world. Okay. And what is the time period? This time period start from 2021 to 2025, this time. Okay. So this time we find out that how many images, this is the total number of images we find out in here. Yeah. So this is the image collection. So this image collection we need to filter. Okay. So now how I can filter the image collection? So for filtering process, first of all, where you need the image. Suppose I need the image for a specific boundary. So I put the boundary. Suppose I need the image for the Dhaka city. Okay. So first filter, it's called the where you need the image. Suppose I need the image for the Dhaka city or any other study area. It can be. So this is the large number of image collection for the whole world, but I don't need for the whole world. I need for a specific boundary. I need for a specific study area. So for that, I simply apply the one function and filtering for the Dhaka city boundary where I need the image. Suppose in this time, this is the full number of image collection, but I need only of those images, which images are available in the Dhaka city boundary. Okay. So for that, I simply use a one function. If you check this function called the filter bounds function, so you can easily get all of function under this section, e.image collection. You can see the filter bounds function. So you can see it's one kind of function, filter bounds. So this function shortcut to filter a collection by intersection with geometry. Okay. Suppose I have a study area or I have a geometry, mainly point, line, or polygon. Suppose I have a Dhaka city polygon. So I want to filter a collection by intersection with geometry. So I need only for those images which images are available only for my study area, only for my geometry, only for my polygon. So for that, we also need to import our study area. We need to import our shapefile. So you already know about that, how to import the shapefile. So previous class I discussed about that, as well as we also use some data set from FAO or USDOS website. So it also give you some uh, boundary polygon you also get from here. So just let me import a boundary area, then we just work with that. Suppose just import the level 2 boundary. So it's a table. So basically this variable is stored only for the boundary. So now I want to filter for my specific study area. So just I take a variable. Suppose I put the variable name is RY and filter this table. And how I can filter RTengine.filter dot equal. What's equal what? Just I put the name. If you get the name easily from here, you can check the, I want to choose suppose administrative level 2. Okay. Then I just paste here and then set equal to Dhaka. So now what happened? So now this is my data set. It provides you all of administrative level 1 and 2 data. So from here I simply filter and select equal to Dhaka. So now this Dhaka boundary is stored in this RY. So now where I need the image. So I find out this is the large number of image collection for the whole world. But I don't need for the whole world. I need only for those images, which image is available for the only for Dhaka city boundary, only for Dhaka city boundary. So for that, I just use a function. It's called the filter bounds function. You can see. And what is the argument for this function? Geometry. And what is the geometry? Geometry, it can be point, line, or polygon. So now I simply choose a polygon, Dhaka city boundary, and it is stored at the RY. So my geometry value is RY. So now I simply take a variable Suppose I put the variable name is, you can put any name as a variable. I put the variable name, suppose filter region, and I call my data set. Just a copy and paste here, because this variable is stored large number of image collection, but I don't need for the all of image collection. I need only for those image which image is intersect with my geometry, which image are only intersection with my geometry. So for that, simply apply dot filter bounds function, and if you check for the filter bounds function have a geometry, I already declared my geometry. If you check Dhaka, and it is stored the ROI, so just I copy the ROI and paste here. So now what happened? So now it's provide you the whole world, all of image collection, but I need only for those image which image is only available for my region of interest for the Dhaka city. Okay, so now let me check how many images are available in the Dhaka city boundary. So same, just I call this variable name and paste here and apply the size function. So now it's computing how many images are available only for Dhaka city boundary. We find out that 176 images are available. And what is the time period? This is the full time period, 2021 to 2025. We find out that only 176 images are available for the Dhaka city boundary. So this is the first condition for filtering, or first filtering process where you need the image. Suppose I need the image for Dhaka city. So for that, I simply import the Dhaka city shapefile in this variable ROI. So just I use the filter bounds function and put the ROI. It's my geometry. So now this function filter this collection intersection with my geometry and find out only for those images which images are available in the Dhaka city boundary. So now when I filtered this variable, when I just simply check how many images, we find out that 176 images are available in the Dhaka city boundary. So this is the first process for filtering. Then second process, how you need the image, how you need the image. So now this image including all of cloud level, but I need, suppose I need the image less than 1% cloud cover. So less than 1% cloud cover. So now from 176 images, I choose only for those images which image will be not more than 1% cloud cover. So this is my condition. Suppose I need only for those images which image will be not more than 1% cloud cover, or 2% cloud cover, or 3% cloud cover. So it also depend. Okay, some place there is no 1% cloud cover, then we need to increase the value and then check. Okay, but we always try to keep the lowest cloud cover imagery. Suppose in this case I want to choose how many images less than 1% cloud cover for my study area. So for that, just take a variable and apply, suppose filter metadata. In the filter metadata, I want to filter from this 176 images. Okay, so just I call the filter region and paste here. And how I can filter the image properties. So basically cloud cover or cloud cover land. So it's called one kind of image properties. If you check the function from here, it's called the filter metadata. If you check filter metadata, so this is the function filter metadata, and this filter metadata, it's need the name, operator and value, and it's shortcut to a filter collection by metadata. Metadata basically it's the image property or image property, suppose cloud cover or cloud cover land. Okay, so now we are just use this function filter metadata and put the name, operator and value. So what is the name? If you check the name basically the property name. Okay, so which property you want to filter? Suppose I want to filter cloud cover. Then operator, we can easily use the different types of operator, less than, greater than, or greater than, equal, different types of operator. And value basically number. So just I use it filter metadata, just I call this function, just I copy and then paste here. So now name, so you can easily get all of image properties name. If you check image properties, just click on here, so you can see all of them we can easily get from here. Suppose I choose the cloud cover, this one, just I copy and further just I paste here and set the operator. Set the operator, suppose less than 1. So less than, set the value for 1. Okay. So now what happened? So now from 176 images, it just filtered only for this image, which image will be not more than 1% cloud cover. Okay. So now let's check how many images we find out less than 1% cloud cover. So just simply use the print function and call the filter metadata and apply the size function. So now it's computing how many images less than 1% cloud cover we find out. So we find out the total 36 images. Okay. So this 36 images is less than 1% cloud cover. And this 36 image is intersect with my study area, with my region of interest, we find out. So this is second process for filtering the cloud cover. And third process, it's called the when you need the image. So now this 36 image time period is, if you check, 2021 to 2025. So this is the time period, whole time period. Okay, but I don't need for the whole time period, I need for a specific time, or I need the image for a specific year or a specific season, summer season, rainy season, or any specific season. Then we simply use a function, it's called the filter date function. Okay, so filter date function. So shortcut to a filter a collection by date range. We can apply the date range. It can be seasonal or monthly or annual. So different types of date we can simply put in here. So now I simply just take a variable. Suppose I put the variable name is the filter date. You can put any name as a variable and call the filter metadata. This one, basically this variable is 36 images. Okay, just I call the filter metadata. So from 36 images, I need only for those image which image is available. Suppose year of 2025. Okay, I need only for those images which image is available year of 2025. So just I put the filter date and mention the time, start and end. So just put here start time. Suppose year of 2025, 1st January, from year of 2025. Suppose December, and if you check last time period is the 22. Just put it here, suppose 22. So now let's check how many images are available between this time period. So let's go try to filter. Just print again and call this variable filter date and apply the size function. So now it's computing how many images we find out. Okay, for this time we find out that only 8 images. Okay, so now if you check, so here I have a large number of image collection for any specific image collection. In this case it's the Landsat 9 satellite data. I find out the large number of image collection. So this image collection I simply filter one by one and to filter. So first filter, I use a function, filter bounds function. This filter bound function help me to intersect with my region of interest, all of my image collection. So we find out that 176 images. After that, I simply use the cloud cover. Suppose from 176 images, I choose only for those images which image will be not more than 1% cloud cover. I find out total 36 images. And finally, we try to find out that how many images available between this time. We find out only for the 8 images. So this 8 image is my final collection. It's my final collection. So when you filter the image collection, always remember that filter bounds function, filter metadata function, and filter date function. Okay, so any question about the 3 function, you can ask me. I try to explain again. Any question, anyone, please?
So it's clear to me, sir.
Okay, thank you. Okay, so now we find out that this type of things, and now I want to get the more information. Suppose this 8 image is not captured at the same time of the year. Okay, suppose in this time period, this 8 image, it's the capture or acquisition time is different, okay, between this time. So I want to check all of information for these 8 images. So how I can check it? So for that, just print the filter date and run it. So now it give you the all of information about this image collection. So it show the image collection because it's a series of images, okay, total 8 images. So that's why if you check the type is the image collection, okay. And how many images? Total 8 element means that 8 images I have. And now click the feature, then we can get all, you can see it show the image. This is the first image, second image, third image, fourth image, fifth image, all of images you can easily find out in here. Okay, so now I want to check the information. Suppose for the first image I need to check the information, second image I need to check the information. Just click on the first image and you can see that this is the total 19 bands, and click on the properties, then I can get all of information. Just click on here. So now if you check, this is the cloud cover, okay, this is the cloud cover land information, this is the collection information, collection number information, this is the acquisition time information. So it's provided with a lot of information, okay. You can see the all of information you can easily get. So for the different purpose in the remote sensing we use this type of information, sun azimuth or sun elevation. So you can see different types of information, then path and row. So different types of information you can easily get from here. So for the first image, okay, this is the first image, then this is the second image, okay. You can see the second image, just click on here, then you can get for the second image cloud cover information. Also you can get all of acquisition information, we can easily get all of those from here. So now this type of single image, it's called the single image, okay, it called the single image. So this type of single image, how I can visualize in my map, how I can display. So let's go ahead to discuss about that, how we can easily display this type of images. Okay, so first of all, if you check, every single image have a ID. We can get this type of ID. Okay, you can see this is the ID. Click on here, then we can get the another ID. So it's an ID. Okay. So we find out that every image have the different ID. Okay. So this ID we need when you work with the single image or single image, only single image. So first of all, if you simply check the information from image, you can see the image. So just click on here. So just click on here e.image. So here we find out that Earth Engine, an object to represent the Earth Engine image. So when you represent the image in Earth Engine, we need to use this function e.image. And then we need to define the directory. We need to define, you can see it can be string and it can be ID, okay? Earth Engine asset ID, okay? We need to define the asset ID in here, okay? So it can be asset ID. So for that, just I copy this function and then paste here, and further simply call this ID. So we can easily get the ID from here. Suppose I want to display this any one image, just same process. Just I click on here and copy this ID. This ID I simply copy. Just I copy. Okay. Just I copy and then paste here. Because it's a image. Okay. For that I simply use the e.image function and define the ID. Define the ID. So now this thing simply store it in a variable. Suppose I put the variable name is any name. I put the name, suppose image, and then equal. So now what happened? So now this image is stored in this variable image. So I want to display this image. So how I can display? We already know about that. Just add the layer, map.add layer, and call this variable. Okay, because it is stored this image. Just I paste here. So now if I run the code, you can see it add a layer. It just add a layer, but not focus on my given study area. But I want to focus on my given study area. So how I can focus? So for the focusing, just use here map dot center object, and center object is ROI. ROI basically it's my shapefile, mainly Dhaka boundary. Okay, and I put the zoom level. Suppose I put the zoom level is 10 and run the code. So now it directly focus on my given study area. So now if you check, we find out this type of tiles, okay, for this area of interest. And what is the acquisition time? If you check, the acquisition time is 2025, 17 December. Okay, 17 December, we find out this time. And we find out this type of imagery. Okay. So now if you check, okay, it's completely overlay with your boundary or not. Okay, it's fill up the boundary or not. So for that, you can also add the shape file layer. So just use here map.add layer, another layer for this study area ROI. Just run the code. So now it's added the two layer, image layer, and also add the boundary layer. So now if you check, we find out this type of scenario. And if you check, some part is missing. Some part we find out the image for this time, but some part is missing. So now how I can handle this situation? So for that, first of all, we need to check all of images. We need to check every image. We need to check every image one by one. Total 8 images. So one by one, we simply check all of images. Which image is fully fill up my boundary or overlay, fully overlay with my boundary? We try to find out this image. So now let's check another image. Suppose I want to check for this image. I want to check. Just copy the ID. Then check what happened for that. It's a 15 November acquisition time. 15 November. Just I paste the ID and run the code again. Now let's check what happened for these tiles. It's fully fill up my study or not. Okay, almost it fill up the study area. If you check, it's fully fill up this study area. Okay. So first of all, we try to check it. Okay. So his tiles is fully fill up my study area when you work with a single date imagery. Okay, so if you check this imagery, have also some cloud, white color pixel. Okay, we try to discuss further later. So now we simply find out this image is the fully fill up my boundary. Okay, you can see this is my this is the image, this is the boundary, and this is the image. Okay, it's fully fill up, it's fully overlay with my study area. So now I want to use it. Okay, so for that, this is my image and this is my boundary. So I simply use the clip function. I simply use the clip. I just clipping with my boundary. Okay, I need the image only for my boundary. Outside, I don't need. So just simply use the function dot clip. Clip with my boundary, which is ROI. Okay, clip with the geometry. Geometry basically ROI. I already import the shape file of ROI. So just I call the ROI, clip with my ROI. So now if I run the code, so we can get the imagery only for my boundary. So now if you check, we find out this type of imagery look like that. Okay. So this is the satellite imagery. We find out that. Okay. And it's called the single date imagery. Single date. So sometime for the different purpose, we need to work with the single imagery, mainly single time or single date imagery. So then we just try to apply it. But it's not, suppose when you work with the big study area, we face some problem because suppose you need the image for the whole country boundary of Bangladesh. So then one tiles is not enough. Then one tiles is not fully fill up. Then we need to compose it. So after some time we discuss about that how to create the composite, mainly just combine lot of scene and then create the one image. Then you can get the better idea. So now this is the image. We find out look like that, and it show the this type of black color. So now how I can add the pen combination and how we can easily add the visualization of the image. So for the band combination, if you okay, so you can simply search here band combination, get more better idea what is the band combination. Band combination in Landsat, band combination of Landsat 8. Just simply search. So you can see different types of band combination to find out in here. Okay, or if you can simply visit this link or also you can see the also visit this type of reference link. Suppose just I open it from here, so we can easily get the idea what is the band combination and how to use this type of band combination in the remote sensing. So basically you can see in the remote sensing, basically we use the different types of band, and bands is the stored the different types of wavelength value. Okay, so you can see some, this is the band name, blue band, green band, red band, coastal aerosol band, near infrared band, short, so different types of band. And when we create the band combination, basically three band make one combination. So if you check the three band, suppose you can see it's one kind of three band combination. So when I just simply use this three band, basically red, green and blue, red, green and blue, it called the RGB, and RGB it create the natural color composite. It called the natural color composite, mainly naturally what human eye can see. Okay, suppose healthy vegetation is a green, unhealthy flora is the brown, urban feature appear the white, and gray water is the blue or dark. So when I am using this band combination, then I can easily get this type of feature, this type of satellite imagery. So let's go try to apply it. So red, green, and blue in my satellite images. So for that, just click on the setting layer properties. This one, and further just click on the, you can see it's a red, then it's a green, and it's a blue. And okay, if you check the another problem, it shows a very large number. You can see 77,237. But if you check the Landsat wavelength value, 0.452, 0.52, 0.52, 0.60, you can see 0.5, very small value. You can find it. You can see wavelength value is the, it's called the electromagnetic values. It's not, you can see it show very small, but in this case we find out very large number. We find out the very large number. So it's called the reflect, it's called the digital number. Okay, DN value, digital number we find out. So this digital number we need to convert into reflectance value. Okay, basically digital number we need to convert into reflectance value. And how I can convert? So for that, they already give some information. If you check the bands, they already give some information, scale value and offset value. They already give scale value and offset value. We can see all of bands are the same scale. Okay, otherwise I need to use the scale value and offset value. It show very large number, and this large number call as a digital number. So you can see this type of mean and max value, very high value. But when I apply the scale value and offset value, then I can get this type of range. Okay, this type of range we find out. Okay, and it's called the reflectance value, mainly wavelength value. Okay, but now it show the this type of digital number. So how I can convert digital number to reflectance value? So for that, simply use the multiply function. Multiply with the scale value. If you check the scale value, this is the scale value. Scale value, just copy and paste here and add the offset value. Okay, always when you find out any scale value in the data set, it can be Landsat, Sentinel, Modis. This scale value simply multiply and add the offset value. So basically offset value you can get only for the Landsat image collection, but Sentinel we find out some scale value, and Modis have also some scale value. So when you find out the scale value, always try to multiply to get the reflectance value. And if you check the offset value, just I copy the offset value, and all bands are the similar. Just I copy and paste here. Paste here. So now run the code again. So now it give you the reflectance value. Okay. When I just add the scale value and offset value. So now further try to add the band combination. Click on here. And I want to add suppose red, then green, and blue. Okay. And then if I just apply, so then this it's added in my image collection. But you can see this image is not more clear. Okay, so for that we simply increase the stress level. Stress level is one kind of image visualization process. Okay, suppose if you check the different types of stressing level, so suppose I choose the 98%. When I choose the 98%, what happen? You can check this minimum and maximum range automatically change, mainly reflectance value range change. So now I apply it. So now let's check. it create this type of imagery. Okay, suppose I want to put another one. Suppose band 5, band 4, and band 2. Suppose this one, you check. So this one 5, 4, 3, I want to apply. Then check what happened. 5, 4, and 3. Stressing, I keep the 98% same. And now apply. So now it create this type of band combination. You can easily find out. Okay, so you can easily get vegetation show as a red color. So when you apply this, you also read this type of thing, you can get the better idea. You can see when you apply this type of band combination, it reflected the near infrared light, and this band combination is useful analyzing for the vegetation. In particularly areas have the better vegetation, okay, for the better red, and dark areas are water, urban areas are white. We find out. So when I apply this type of band combination, so you can see get this type of thing can easily get. So you can easily identify vegetation, this type of red color, okay, and this type of black color, it's a water body. You can easily get the idea, it's a water body, okay, and this type of place is the vegetation. You can find out it's a water body. Okay, so now this is the band combination, and this band combination I want to import in my code editor. Okay, I want to import in my code editor. So for importing, you can see the import button. Just I click on the import, a new line of code added in my code editor. Just copy the variable and paste after the object name. Just I paste the object name. Okay, so now what happened? So now this for this image, this visualization I set it. Okay, further when I run, you can see it is still keep the visualization. We find out this type of visualization. Okay, and if you check it, there is no name. It shows the layer 1, but I want to add the name. So for that, just simply apply layer names. I put the layer name. Suppose it's called the, put any name. I put the name, suppose false color. So now run the code. So you can see get this type of things. And if you want, you can also just comment this line. Suppose this layer I don't need, just a comment. Okay, so when I comment and run the code, you can see it just show only for the one layer, only for the image. Just it show only for the one layer. Suppose I want to add the another band combination. Okay, suppose another. So for that, just same process, just click on here. And I want to add, suppose short wave infrared 1, near infrared, and blue. And then stressing 98% I keep, and apply. So now it's create the another visualization. We find out this type of visualization, this satellite imagery. Further, just I import. Okay, when I import, you can see what happened. A new line of code added in my code editor. Okay, this one. So now I want to add the another layer for this visualization. So how I can do it? So simply add the layer, map dot add layer, and I want to add the layer for this image. But now I want to add the another visualization, this one. Just I copy the name and paste after the object name and put the layer name. You can put any name. I put the name, suppose it's a vegetation, or you can put any name. So now run the code. So now you can see it create the two layer, identify two different visualization, two different visualization band combination. We find out. Yeah, it's created the two layer. So using this way, we try to add the different types of band combination, and it also very helpful. So further, we'll also discuss about that more details, how to work with this type of band combination for creating the land use, land cover classification. We'll also discuss about that. Then you can get the more better idea how to use for the land use and cover classification. Okay. So this called the single image or single date image. So now we talk about the image composite. Image composite and how to work with the image composite in Google Earth Engine. Okay, anyone question about it, then you can ask me. Or any confusion? I hope there is no question. So let's wait, continue for the image composite and how to work with the image composite. So image composite is a single image created by combining multiple satellite images over a given time period and area. Suppose in this case, I want to create the median composite or different types of composite. I try to explain. So we create a single image. This is the definition. We create a single image, but this single image created by combining multiple satellite imagery, combining multiple satellite images. Suppose here we find out the total 8 images. Okay, so I want to create the composite using all of images. Suppose I just use all of images and create the composite. Yes, but in this case it's just show only for the single image, but I want to create the composite using all of images. So I create a single image by combining total 8 images. Okay, it called the composite. And why composite are needed? So what is the benefit for the composite? So let's wait to discuss about that, then you can get the better idea. So why you needed the composite. So first, it helps you to remove cloud and cloud shadow. Okay, so when you create the composite, it helps you to remove the cloud and cloud shadow. If you check in my single image, I find out some cloud, this type of cloud, but when I create the composite, it this type of cloud is automatically removed, and we can get the very neat and clean satellite imagery. So this is the one benefit to use the composite. Second benefit, it produces more stable image. Produces more stable and representative images. Okay, so this is another one. So this image, it's the more stable, and all of noisy pixel it automatically remove, as well as it also improve the visual quality and analysis accuracy. Okay, so it doesn't help. So this type of things, it for that we need the very we can use the different types of composite. Okay, so this is the benefit to use the composite. Okay, as well as types of image composite. So we are use the different types of image composite. So types of image composite. So types of image composite, we can combine the image across the time. Okay, suppose daily, monthly, seasonal, annual. So this is the image across time. We can combine the image. Suppose daily image, we can easily create. Suppose it's called the time based or temporal composite. Suppose temporal composite. It including, suppose first one, it's called suppose daily to monthly. Suppose I have some daily image, so then I can easily create for the monthly. And suppose I have some monthly image. So this monthly image I can easily create for seasonal composer I can create. Suppose I have some seasonal image, seasonal image. So we can easily create for seasonal to annual composite. So you can see it's the temporal composite. Okay. So another composite, it called the statistical composite. Okay, it's called the temporal. So in the temporal, we are just use this type of example. Another one, it's called the statistical composite. Statistical composite based on the pixel wise statistic. Okay, it's called the statistical composite. Okay, in the statistical composite, what we can do? So first number, it's called the median composite. So it's the most common we use, and it help you to remove the cloud easily. Okay, it's most common, and we can easily it help you remove the cloud from your imagery. Second composite, it's called the mean. Third composite, it's a statistical, it called the maximum and minimum. Then as well as we can also use another composite, it's called the percentile. So this type of statistical composite you are used in remote sensing, as well as also band combination. We already discussed about that. Band composite, false color, true color. So this type of band combination can use to display. So now suppose I have total 8 images. Okay, so now I want to create the single image by combining multiple all of satellite images. Suppose I want to apply the median. Okay, so how I can apply it? Very easy. Just take a variable. Suppose I put the variable name is median image. Okay, so now I want to create the median image, help of total 8 images, and this 8 image is stored in a variable. What's the variable name? This variable name is filter date. Okay, so you can see when I use the filter date and use the size function, then I can easily get the 8 images. So I want to use all of images and create the median composite. Just I copy the variable name, because this variable is stored the total number of images, and apply the dot median function. Okay, so now just click with my study area RY. So now display the median composite image for my Dhaka city boundary. So just call this median image, just copy and run the code. So now it's create another layer, but now we are just combining all of images. Okay, all of images, and create the median composite. So now you find out this type of imagery. Okay, basically this layer, add number layer. So I want to add the visualization. Just click on here. And if you check it, show this type of problem, it show the result, it show the digital number. So same process. After creating the median, I simply just copy the multiply and also offset the add. Just I copy these things and connect in here. Just paste here. Okay, to convert digital number into reflectance value. So now run the code again. So now further just add the visualization. I add suppose red and put the green, and I put the blue, and stressing I keep 98%, then apply. So now if you check, we find out, just import the visualization again. So when I click on the import, a new line of code will be added in my code editor. If you check, just click on the import button, it added the new line of code. Just I copy the visualization parameter variable and paste after the object name, and this is my object name. Just I paste here, just paste here, and put the layer name. I put the layer name. You can put any name. I put the name, suppose median. So now run the code. So now if you just compare the image, so we can see which image is more better. We can get the median image is the more better. Okay, because this median image, if you check, there is no cloud, there is no haze. It is very neat and clean satellite image. We find out if you just compare with the single rate imagery. So you can see this is the imagery. Okay, for the median composite, we can easily identify. And this image is very neat and clean. There is no cloud, there is no haze, there is nothing. Okay, it create very neat and clean satellite imagery when I apply the composite. But if you check, when I just apply it for single date imagery, what happened? You can see, find out the lot of cloud, lot of shade, lot of things you can easily identify. But when you apply the median image, when you create the composite, we find out the very neat and clean satellite imagery. So this is the power of composite. Okay, so when you're using the composite basically it's called the set of multiple images. Okay, we just simply apply the multiple image and create the composite. Okay, combining multiple images and create the single image. So in this case, I just have total 8 images. So I want to use all of images and create the single image. And this single image called the median image because I apply the median composite using all of 8 images. So filter date, this variable stored total 8 images if you check. Okay, so just I simply call the filter date and apply the median function, and then we can get very neat and clean satellite imagery. And this imagery is more clear. So now we can easily use it for the different types of remote sensing analysis, for land use, land cover, or vegetation analysis. Different types of things we can easily do it using that. Okay, so it's called the composite. Okay, I hope you also get the idea how to work with the composite and when you need the composite. Okay, so this is the benefit to use the composite, as well as when you work with the big study area. Suppose you need the satellite image for the whole country boundary of Bangladesh, so then one tiles is not enough, so then we try to apply the composite. So you also try to create the image composite for your own country. Okay, I also give some assignment regarding this type of topic. So you also try to create a image composite for your country boundary. Right. That was in 2025. Okay, in 2025 to create the image composite for your country boundary and display the natural color band combination. Finish. So you also try for your own country, simply import your country boundary shape file and not use this type of just copy and paste. Not use that, because when you just copy and paste, then you don't become a developer. So you try to understand this type of every single line of code, and further you try to write. Okay, so it will be best practice. But when you just copy and paste, then you can don't become a developer. Just simply copy and paste and then work. And lot of code is already available in the online. Okay, just we simply copy and paste, we can work with that. But first step, we need to understand all of function, how it will be work step by step. Okay, then you can just become a developer, because there are the lot of source for the code. There are the lot of source. We can use the different types of AI, or we can, there are the lot of site we can easily get this type of code. But when you understand this type of code meaning, okay, what is the image collection step by step, when you know, then you can easily modify this type of code and you can do a lot of things. Okay, and then you become a developer for in this type of coding. Okay, so now we try to explain this type of things, how to work for that image collection. So this type of image collection we can also export. Suppose this image collection I simply export, and further I want to work with the other GeoSpatial software, ArcMap or QGIS software. It also possible. Okay. So let's try to discuss about that. How to export. How to export satellite imagery. Okay, so before that, I also try to show you then another example. Suppose let me open the another code editor, and this same process you also apply and try for, you can see Landsat 8, same process you can also apply. Landsat 7, Landsat 5, all of image collection you also try. Okay, for the Landsat series, all of image collection you also try. Further, you also identify some problem. Okay, so then we'll also discuss about this type of problem. Suppose when you work with the Landsat 7, then you can get some problem. Some imagery have the dotted line, or some imagery have the scatter, or different types of image problem you also find out. But you also try first for the Landsat 7, Landsat 5. Landsat 5, there is no problem. Mainly we find out the problem for the Landsat 7 for this type of problem, mainly dotted line or a scattered line or gap, okay, between the different types of tiles. So you try to Landsat 7 also. Landsat 8, there is no problem for the image. Landsat 8, 9, 5 you also try. So all of those you also try for the different year to get the satellite imagery for the Landsat. So now I discuss about the another image collection for the MODIS. Okay, so for the MODIS, you can see we find out the different types of product, and this MODIS, it's called the ready-made product. It's a ready-made product. Okay, suppose if you check, this is the data set, it called the crop vegetation continuous field yearly. This is the yearly data set. And if you check this data set, basically give you the different types of information. So far they also try to read it, this type of things. Click on here, then you can get the lot of information about this data. Okay, it provide you the percent tree cover. Okay, percent of pixel which is covered by tree canopy, percent non-tree. So you can see different types of band. It's give the different types of information. We also try to read this type of things after the class. So if you check, we find out a lot of data. Okay, you can see the ocean color. This is the land cover data for the MODIS. Also, you can see this is the leaf area index data, okay, for the MODIS. Sun radiation data, okay, daily data per 3 hour. Photosynthetical activity data. Okay, so basically this type of data were used for the different types of remote sensing analysis, for the different types of research work we also use. You can see this is the aerosol optical depth or AOD data. Then MODIS albedo model parameter data we also use. Then model albedo quality data. MODIS, you can see the BRDF data, adjustive reflectance data for the MODIS. Also, you can see the MODIS band area we also get from here. Mainly band area we also find out from here. Then atmosphere monthly global product, then surface reflectance data. So it provides a lot of satellite product. This is the LST data, land surface temperature data. Okay. So also you can the vegetation indices data. So this type of data we are used for the different purpose in remote sensing. And when you work this type of data, almost we always use the same process. Same process we always skip. Okay. So let me show you the one example. It will be more better. Suppose I want to work with this data. Suppose I want to work with this data. So this is the one kind of data. Basically, just I click on here, then get the all of information about this data. So this data set, this is the name about the data set, and this is the code about this data set, and it's called the crop vegetation indices 16-day global 250-meter resolution. This data, and if you check, the data set is available from this time period. Okay, and update every 16 days. Okay, update the data every 16. We can get the data every 16 days. Or it's called the temporal resolution. Temporal resolution is 16 days. Okay, and this data set, if you check, we can get the snippet ID. Okay, as well as if you check the band, we can get the two band, NDVI and EVI. Okay, normalized difference vegetation and enhanced vegetation we can get from here. So this data set resolution is 250 meters resolution or pixel size. So now how I can use the data? Okay, so first of all, simply just copy the snippet ID of this data and paste here. Okay, then give a variable name, any name you can put, any name. I put the name, suppose data set equal. So now what happened? So this is the image collection. I just stored it in this variable, and this image collection have different types of band. If you check, this image collection have different types of bands, and one band is called the NDVI. Suppose I want to work with the NDVI, just I copy the band name and then apply dot select function and apply the NDVI. Okay. So another important thing is that I also miss in this part. So you can see here in this code, I simply explain line by line. So that's why you can say I take the lot of variable. So every function, I take the different variable. I take the different variable, but it's not mandatory to take the every function just at the every variable. It's not need. If you want, you can just simply take the only one variable, and under this variable just put all of function. Okay, suppose let me show you this process also. So this thing I simply comment. Suppose just I comment all of those, simply comment. Okay, so now I just simply call. Suppose just I put the all of function using the dot notation. Just put the dot filter bounce function. Okay, with my study area RY. Then I put here the dot filter metadata function. Okay, then put the property name cloud cover. Then it's put the operator less than, set the value for 1, less than 1%. Then put here the filter date function, and put here cloud cover. Sorry, put the date 2025 1st January from 2025 December 20 I put. So you can put this table. You can see now I just take the only one variable, and under this variable simply put all of function. Okay, but previous time you can see I just simply use the different variable and run the code. So now finally I simply apply dot median. Okay, dot I create the median composite. Further I simply multiply. So dot multiply with the scale value. The scale value basically this one, and also add the offset value. This one is for offset value. And finally, I just use the clip function, clip with my study area, which is ROI. So now you can see, I just use only one variable, and under this variable, I put all of function together. So now this is my final function. Just I copy, and I want to display it. So for that, I simply comment this line also. .NET, I simply display my final output data set. So now if I run the code, there is no problem. Okay, you can see it work. You can see it create the median image. There we find out. Okay. But now you can see I just simply put only for one variable. Okay, under this variable I simply write all of those. But first time I simply explain how it will be work step by step. So that's why I simply explain and break down all of function one by one, one by one, one by one. But when you just become a developer and you learn all of those, just simply use this, take the one variable, and under the variable put all of function. Okay, so it short is your line of code. So the same thing I also apply in here. So just I take the select function and put the band name. Okay, but if you want, you can also take the another variable. Suppose you can also write this way also. Suppose just I take a variable, I put the variable name, suppose ndvi, and then I call this data set, and then put here the select function and call the ndvi. So you can see now I take the another variable ndvi, and I call this data set and select the band. But these things also increase my line of code. So for that I just simply use the same line, and then use the dot select function and put the ndvi. Okay, it's very okay. So now I put the another suppose filter, and if you check the ready-made data set, there is no property, there is no image property. The ready-made data set, okay, there is no image properties. But for the Landsat, Sentinel, we find out that image property, cloud cover land, and it's a ready-made data set. That's why if you check this type of water, cloud, heavy aerosol, or cloud shadow, it already removed from my satellite imagery, from already removed this data set. Okay, so that's why when I use this data set, it gave me very neat and clean NDVI map for the big geospatial area. Okay, So that's the region. It's a ready-made data set. So that's the region. There is no image property. There is no image property. Okay, but Landsat, we already checked some image property. So for that, we simply use the filter metadata function. But now there is no need to use the image metadata because there is no image property. I simply use the filter date function. Filter date. So now I need the data, suppose 2025 or 2025, 1st January from 2025. Let me check the last time period. It was December 3 December. Okay, December 3. So now let's check how many emails we find out. Just I print and call this data set. Just call this data set. Just I copy and paste here and use the size function and run the code. So you can see that is we find out the 21 images. Okay. So now if you want, I want to display the map dot add layer, and I call the data set and run it. We can get this whole world NDVI map without color. It look like that, but I want to add the color. So for that, there already gives some color demo code. Just copy the color demo code and then I paste here. Basically in this time they are create a dictionary. If you check it, a dictionary. So they are mentioned the mean and max range of NDVI and also add some hexa color code. Okay. So just I copy the variable of visualization parameter and paste after the object name. And I put the layer name, suppose it's a NDVI map, and run the code. We can easily get this NDVI map for the whole world. You can see you can get it this type of map. Okay. Get this type of map for the whole world NDVI map. But I don't need for the whole world. I need for a specific boundary, or I need it for a specific polygon. So let's go try to discuss about that, how we can easily work with the polygon. Suppose I need the reason only for the specific country boundary or a specific shape file. So for that, you can simply import your shapefile boundary, US DOS website. Just I paste. And further, just I filter my boundary. So take a variable, suppose ROI, and call the table. This table I want to filter. How I can filter? ArcEngine.filter dot equal. What's equal what? Put the country name and put the country name. Suppose I need the result for Bangladesh. Just I put the Bangladesh. So now what happened? So now this ROI stored the Bangladesh boundary, and I need the result for Bangladesh boundary. So now if I just use the clip function, if you check what happened, clip with my ROI and run the code, it show a problem. Okay. And it's very important. A lot of time we face this type of problem. It show the result image collection dot select dot filter date dot clip is not a function. So clip, this function is not work in the image collection. Okay. So from where you can get the idea, one idea. Suppose image collection in this image collection data type clip not work. Okay. This image collection data type clip function is not work. So clip function work only for image data type. Okay. So you remember that, and how I can understand about that? If you check the function docs tab and find out the image in the image section, you can easily identify clip function. You can see the clip function is available in the image data type. Image data type. Okay, we find out the clip. So clip we find out under the image data type. Okay, so it means that this clip function is only work for the image data type. Okay, and if you check the image collection, there is no clip function. There is no clip function. We find out there is no clip function in the image collection. Okay, so now if you check in the data set, it's an image collection. Okay, it's an image collection. And how many images we find out that if you check how many images, we find out that total 21 images we find out. Okay, so that's the region. It's a collection. It's a image collection. And image collection, this function is not work. Image collection, this function is not work. So for that, what the solution? Okay, so we need to create the composite. Okay, we need to create the image composite. And what is the image composite? Image composite, create the single image, help of multiple images. Okay, suppose I have 21 images, I just use all of images and create the single image. And in this case, we create the mean NDVI, mean NDVI, mean NDVI. Suppose I create the average NDVI, help of total 20 images. Okay, so now how I can do it? So for that, simply use dot, or if you want, you can take the another variable. Suppose just I take the another variable and show you the result. Suppose just take a variable. Suppose mean NDVI. Okay, you can put any name and call this data set. It is stored total 21 images. So this total 21 images, I create the average composite, and then click with my study area. And when I put the mean on, when I create the image composite, it just work as a single image. Okay, composite mainly reduce the image. It reduce the image and create the single image. So now it create the single average composite image. And I click with my study area, which is ROI. So now display the result, map.add layer, and call the mean NDVI and run the code. So now it display the result. If you check, it create the another layer. So this is the first layer. So it creates the layer only for the Bangladesh boundary without color. We find out this type of map. So now I want to add the color on my map. So for that, if you want, you can simply just use the same line of this color. So for that, this line of code, we simply copy, and below the visualization code, simply paste. Okay, this line, and then I put the layer, put this same color, just I copy the name and set after the object name, put the layer name, suppose NDVI, just run the code. So now we can get the color for this Bangladesh boundary also. We can see the two layer. So this is the NDVI map for the whole world. This is the NDVI map for Bangladesh boundary. We find out. Okay. Not only for Bangladesh, suppose I need the result for another country, I simply change the country name. Suppose I put the country name for Australia. Just run the code. But it not focus. You can see it is still to the Bangladesh boundary. Not focus my given study area. So for that, we simply use a function. You already know about that. Map dot center object. I want to focus on my given study area of Australia and run the code. So now I can see it just show the result. So you find out. Suppose you don't need for the first layer, so this layer you don't need, so you can simply comment. So now this layer is not loaded, just it loaded only for the one layer. So now I can get this type of map only for the Australia boundary. So now we can try to check any study area, any country boundary, because this data set, it large international country boundary polygon. It just provide you all of international country boundary polygon in the world. We can easily identify from here. Yeah. So any country boundary, you can simply try, and then we can get the result. Suppose I simply use here Kenya. Now run the code. So now I can easily get this DBA map for this area. Can get this type of map. So any country boundary, simply choose, and then we can get the result for that, or any shape file. So you already know about that, how to import the shape file from here. Okay, asset tab. So you can simply upload your own shape file and further just use it for make the map. So now if you check, this map have a problem. And what's the problem? If you check it, click on the Inspector tab and check the image pixel value, NDVI pixel value. Just click on here. So now I can see it show this type of value, negative 1288. Click on here. We find out this type of value, 2507.52. So click on here, 7,000. But if you simply search here the Google, NDVI range, NDVI range values, then we can easily get the result. Normalized difference values from -1 to +1 with the different values you can see. So you can see 0.1 to show his range, we can get F specific range. So but values will be this range, -1 to +1. But now in the my case, it show very large value. Okay. You can also check this link. So in this case, you can easily identify, you can see NDVI value range from +1 to -1. And areas of barren rock, sand, and snow usually show very low NDVI values. And sparse vegetation, such or shrub or grassland or extensive crop may result, you can get 0.2, 0.5, this range. And high NDVI values 0.6 to 0.9. Okay. But now if you check, I find out this type of value, 7,189. Just click on here, you can get this type of value. So now what's the solution? What's the solution for that? So for that, I already said about that. When you work with any data set, if you check, is there any scale or not? If you check, this data set already have a scale. If you check, the scale value is the 0.001. So when you check any data set have the scale value, you must use it. Otherwise, it show the wrong reflectance value. Okay. So this scale value I need to use. So how I can use it? Just a copy. And now I simply multiply this scale value with these things. Just I after create the image, I simply apply the multiply function and paste. So now it give me the proper range of NDVI when I just multiply with my scale value. But now we can see it show this type of white color because I also need to change the mean and max range in here also. So I put the value, suppose manually, suppose put the -1 and +1. I simply put this type of value and run the code. But this map is still not showing the better visualization. So okay, if you want, you can check the result. So now it shows the proper value, -0.09. We can get the proper NDVI range, but this visualization is not proper. So further is simply stressing the data and just click on the stressing 98%, or any stressing you can also use. For the visualization, I use the different types of stressing. So I use suppose 98%. And now it just show me the mean and max range. So just I copy this mean value and then paste here to achieve the more better visualization. Also copy one, paste one. So now just run the code. So now it show the more better visualization we find out. Or if you want, you can also use your own color. It's also possible. Suppose I just simply remove this type of hexacolor code. I simply put my own color plated. So I put the suppose this type of color, suppose blue, then suppose white, and then suppose I put here that green color for the width. You can put any colors, then run the code. So now if you check, we find out this type of NDVI map. So then we can easily get the vegetation area of this area. You can see this type of green indicating about the vegetation. And this type of place we find out that water body. If you just simply check for the water body pixel of NDVI, it shows the negative value. Okay, you can see the negative 0.1. And if you check the vegetation green color, so it show the positive NDVI value 0.7. It means that dense vegetation. Okay, 0.7, it means that dense vegetation. Click on here. 0.8, it's called the dense vegetation, this area. See, and again this type of place is the water body. So now we can easily, there are a lot of application of the NDVI. So if further you also try to read this type of things, then get the more better idea, and also search some paper for the NDVI application, then get the more better idea how to use NDVI in the remote sensing for the different purpose. Okay, anyone, any question, please? This NDVI map. I hope there is no question. Okay, so let's go now. I try to show the one example. So this type of things, how we can easily use the Python. Okay, so for the Python, we can use the two code editor. One is the Python Google Colab. We can also use, as well as we can also use the Anaconda distribution, mainly Jupyter Notebook. We can also use for that. So you can use anyone, same process, as well as we can also use the ArcGIS Pro. Mainly ArcGIS Pro, we simply use the Python code. Okay, basically ArcGIS Pro, we simply use the Python code, but there is the benefit, it automatically added the layer on ArcGIS Pro. We can, or it automatically add the layer. Suppose when I add the layer in my Python script, then it automatically add the layer on the ArcGIS Pro. So let me show you the one example. It will be more better. Just let me connect with my ArcGIS Pro and show you that process also. And okay, so I think, and our another condition to get the certificate, all participant must be join our online training session. Okay, otherwise they cannot verifiable for getting the certificate. Okay, only for the recorded class, if not provide the certificate. All of you student must be join the live session to get the certification. Okay, so let me show you that. Okay, let me share my screen. Okay, can you see my screen?
Yes, sir.
Thank you, sir. So now this is the ArcGIS Pro. So I already set up my environment in the ArcGIS Pro. So now I'll try to show you that how we can easily add the layer. So same code which I already write in the our Google Earth Engine, okay, using the JavaScript API. Same thing we also try to discuss how to work with ArcGIS Pro, okay, mainly Python environment. So here you can open the ArcGIS Pro and further click on the analysis. From the analysis, we can get the Python. You can see the Python notebook. Open the notebook. So this notebook is simply write our code. And then when I write complete our code, when I add the layer, this layer is automatically added in my ArcGIS Pro map layer. It automatically added. So this is the benefit to use the ArcGIS Pro. Okay? Not need to download again, because we connect the server of Google Earth Engine directly with the ArcGIS Pro software. It's also possible to use the also QGIS software also. But ArcGIS is more better. So I'll try to show you the another class how to work with the QGIS for the another dataset, but similar process. So all of the dataset are the similar process to work. It's loading. So this is our notebook. So first of all, we simply import our important library. So just import Arc Engine library and also import the map library. Just run the code. And now it's loading. Okay, done. There is no problem. It means that my ArcGIS Pro software, it already installed it all of packages, or everything is completed. There is no problem. So now just put here EE dot indicate authorization. Just run this code. If there is already true, because I already connecting, or authorization is already done. First time it need mainly click on the allow, and then just check mark. Yeah, other time it's not need. Then just EE dot realize your project. Okay, project, mention your the project name. My case project is an E690. Run the code. So now there is, it's working. Now this corridor is ready to use. So first of all, I need to import my data set. So let me show you that. Just I open, okay, Art Engine data catalog. Simply go to the code editor. So you can apply the same process for Landsat, Sentinel, Modis, or any others. Okay, just apply the same process all time. Then browse data catalog. And I want to work, suppose Modis NDVI data. Just click on the Modis. The Modis, I want to work with Modis NDVI. Data. Okay, just click on here. Yeah. So now just I use the same line of code, just copy the snippet ID and paste here, and then give a variable name. I put the name, suppose dataset, or any name you can put equal. So now run the code, there is no problem. So now I want to use the same line and put all of those. Okay, just put the dot select function and select the band name. Band name is NDVI. Okay, then I put another one, dot filter date, the time period. Suppose I put the time period is year of 2025 January. Goes from year of 2025 December 3rd December. Okay, so now you check if I run the code, I think it shows some problem, get this type of problem. So now what the solution for this problem? So for that, just simply start the first bracket and also close the bracket. Okay, so now run the code, I hope it will be okay. Oh, same day we get the problem again. So filter date, what's the problem? Intermediate signal line 2. What's the problem? The problem, it show the problem. Okay, you can also use the symbol. Now let's check what happened. Because Python is the also space sensitive. Okay,
Sir, after the 2025 December 03, you can put the
oh sorry, thank you.
yeah.
Yes, so now I hope it will work. Yes, thank you. Okay, there is no problem. So we can simply put this quotation also. Okay, and then further just start bracket and close the bracket. Okay, so now further I will check how many images we find out this data set, and then use the size function, run. 20 image, if one image we find out that, okay. And further, just take the new cell. Suppose I want to use all of image and display the map. Okay, same, just or I just simply use a boundary. So further, I need to import the boundary shapefile also. Okay, then, okay, so let's try to create this boundary. We can easily get the boundary shapefile from USDOS website. Just simply search USDOS website. This is the data set. Just I copy and further paste in here, and then give a name, suppose table. This table further we filter. So take a variable, suppose RY, and call the table. I want to filter. Put here how I can filter Earth Engine dot filter dot wall. What's equal what? Put the country name. Put the country name. Suppose I put the same country for. So now what happened? Kenya boundary is stored in this RY. Now run it. There is no problem. So now I want to create the mean NDVI. Suppose mean AVI. Just call this dataset. Destroyed all of image collection. I want to create average NDVI, and further clip with my study area, which is RY. Okay, I also need to scaling. For the scaling, after creating the average, we simply apply the multiply function and multiply with our scale value. Okay, so in this case, our scale value is 0.0001, 0.0001. So now it creates this mean NDVI layer. Just I run it. Okay, there is no problem. So now we simply create the visualization parameter. So for that, I put the variable as NDVIS, NDVI visualization parameter. Well, so create a dictionary. The dictionary we simply mention mean. So I put the mean value of NDVI negative 0.11 in this value. Then put the max. The max value was 0.87 or something like that. And put the another one. It's called the plated. I put the color plated of list. Put the suppose blue color, and put here suppose color. Okay, so after that, just simply add the layer. So put here. So for that, just take a variable map, GE map, and add the map. Okay, and further map dot add layer. Call this mean NDVI. This thing, just take copy and paste here. Then call this visualization parameter. Then put here layer name. I put the layer name, suppose NDVI. And further also map dot center object to visualize of your given study area, which is RY cumulative 10. And further this MAF map, this variable I simply call. Okay, then when I just call this variable, it add the map layer also in here also. Just run the code and check what happened. It's loading, and if you check, already added the new layer Kenya and DVI in the left side. Okay, and now it's loaded from Google Earth Engine. If you check the map, just click on here, you can get it. You can see this is the final output we find out. So now this result is generated from Google Earth Engine server and connect with my Google Earth Engine ArcGIS post map view. So this is the process. So further, we can easily create the map layout. So I also try to part the class how we can easily work with that. So in the meantime, we also try to add the satellite image. Okay. So I already show you that how we can easily work with the Landsat satellite data. So you also try to write the code in the Python for the displaying the satellite images for your study area. Any study area, we try to visualize for the satellite data and directly connect the with ArcGIS Pro in this layer. Visualize this satellite data also. Any question, please? I hope there is no question. We simply make a break for 10 minutes, then we start again. So after 10 minutes, we simply connect again and then continue our class.